Hi everyone, this lesson is on the periodic table. The first topic in this lesson is on orbitals, where we will learn what an orbital is and how the trends of orbitals can be seen in the periodic table. The next topic is on ionization energy, where we will learn that ionization energy is the energy needed to remove an electron, and then we will look for ionization energy trends in the periodic table. Next, we will look at electron affinity and see what electron affinity is and how its trends can also be seen in the periodic table. After that, we will look at atomic radius and see what atomic radii are and how we can compare them. The last topic is on the classification of elements, where we will learn how and why elements in the periodic table are grouped together.
Hi everyone, my name is Abigail and I'm from Massachusetts. Today I'll be talking a little bit about orbitals. One way to define an orbital is a function used to calculate the probability of finding any electron of an atom in any specific region around the atom's nucleus. A second and simpler way is the space or region where the electron is likely to be found the most. Each orbital can hold up to 2 electrons. The closer to the nucleus an orbital is, the lower the energy level is. Since electrons tend to occupy lower energy orbitals found closer to the nucleus, the probability of finding an electron is higher when closer to the nucleus. Now, I'll touch briefly on the 4 basic types of orbitals: S, P, D, and F. Starting from the top of the pyramid is the S orbital. One row down are the p orbitals, followed by the d orbitals, and finally the f orbitals. It may be worthy to note that the s and p orbitals are the most common. It is also important to mention that p orbitals can house more electrons than s orbitals, d orbitals can house more than both s and p orbitals, and f orbitals can house the most. The periodic table shown here indicates the general relationship of each element's outermost electron orbitals, also known as valence orbitals. As you can see, the alkali metals and alkaline earth metals do not have many electrons, so these elements have s valence orbitals. Due to increased amounts of electrons, most of the lanthanides and actinides have f valence orbitals. Hopefully that helped.
Hi everyone, my name is Caitlin and I'm going to be talking to you about ionization energy. Ionization energy is the amount of energy needed to remove an electron from a gaseous atom or ion. There are different types of ionization energy. The first ionization energy is how much energy is needed to take the first electron off the valence shell. After this first electron is taken, the amount of energy needed to remove another electron is classified as the second ionization energy. Depending on how many electrons there are on the valence shell of an atom, the ionization energy can change. The periodic table can help us determine ionization energy. But before we can see a trend in the periodic table, we have to understand why one atom may have a higher ionization energy than another. Atoms want to be stable. When the valence shell of an atom is full or almost full, it's much easier for an atom to gain electrons in order to stabilize rather than lose electrons. So the more electrons the valence shell has, the more energy you'll need to take an electron, because the atom would rather just gain an electron. Also, the less orbitals an atom has, the more stable it is because it's more compact. So again, the harder it will be to take an electron from it. Now that we know that atoms with few orbitals and full valence shells have high ionization energies, we can draw a line or a trend in our periodic table to showcase the ionization energy. This trend will go from low ionization energy up to high ionization energy. To start, we will start in the bottom left corner, low ionization energy, because this is the area with lots of orbitals and only one electron on the valence shell, which can be easily lost. The line will then go up to the right top corner, where there is one orbital with a full valence shell, a tightly compact, stable atom that doesn't want to lose any electrons. This is going to be high ionization energy because a lot of energy is required to take an electron from this area. I hope this helped you learn ionization energy.
Hi everybody, my name is Julia and I'm from Massachusetts, and today we're going to be talking a little bit about electron affinity. So, the first thing you need to know about electron affinity is that it's defined as the ability of an atom to take electrons, or the ability required to remove an electron from a negative ion to produce either a neutral atom or molecule. So, using this definition, we know that electron affinity is actually the opposite of ionization energy. So, when we look at the periodic table depicted here, when we go down on the periodic table, electron affinity lessens because the atom is bigger, less pull from the nucleus. When moving to the right on the periodic table, electron affinity actually strengthens because the atoms get closer to full valence shells. Hi everybody, it's Julia again. I'm from Massachusetts, and today we're going to be talking a little bit about atomic radius. So, the atomic radius of a chemical element is the total distance between the atom's nucleus to the outermost orbital electron. This gets a little bit tricky because determining atomic radii is difficult because there is uncertainty in the position of the outermost electron. We cannot exactly predict where it will be. Because of this, the atomic radius is measured based on the distance between the nuclei of two bonded atoms when we're discussing molecules. When we're just discussing atoms, it is most useful to just compare atomic radii of different atoms. Adding on to our previous slide, the atomic radius of atoms increases as we travel down the periodic table because there are more valence shells the further down we go. The atomic radius of atoms increases as we travel left on the periodic table because as we travel left within a row, also known as a period, the atomic numbers are smaller, and therefore the number of protons is smaller. With a smaller positive charge coming from the protons in the nucleus, there is less of a pull on the electrons, so the atomic radius is bigger. Hi everybody, it's Julia again, and I'm from Massachusetts, and today we're going to be talking a little bit about the classification of elements. So scientists look for patterns using the periodic table to help better understand, study, compare, and contrast properties. Elements are organized in vertical groups in horizontal periods, with atomic number, also known as the number of protons in an element's nucleus, increasing with each period. Elements are grouped together based upon similar properties. The 9 basic groups are alkali metals, alkaline earth metals, transition metals, other metals, metalloids, nonmetals, halogens, noble gases, and rare earth elements. These are some fun, helpful, and interesting periodic table facts. So each group on the periodic table contains elements with the same amount of valence electrons, causing each group to react similarly when they gain or lose electrons. Scientists use this information to predict the properties of elements and compounds based on their locations in the table, making it easy to classify elements into their specific groups.